Bem-vindos to one more episode of the Type Theory for All podcast. As always, this is your host, Pedro Abreu. And in this episode, I have the great honor to interview a living legend in the field of programming languages and type theory. Philip Wadler is a well-known, celebrated, and recognized researcher in the field, especially for his unique ability to explain complex ideas in a simple and elegant way. He got his Bachelor at Stanford, his Master's and PhD at CMU, and in 2023, he was awarded the distinguished honor of being elected a Fellow of the Royal Society, joining ranks with the greats of such as Isaac Newton and Charles Darwin. Philip Wadler describes himself as someone who likes to bring theory into practice and practice into theory. In this episode, we talk about his prolific research, the story behind Monads and Type Classes, category theory, and homotopy type theory, among many other things. Throughout our conversation, in response to my eagerness to understand the philosophy and method behind his remarkable papers, he repeatedly emphasizes that the whole point of science is to clearly communicate ideas so that others can build upon them. Before we dive into today's episode, I want to share something I've been working on. Grad school application season is open, and thinking about this, Type Theory for All is launching a graduate school mentorship program for students applying in computer science, especially in PL and formal methods. The goal isn't just to help you to get into grad school, it's to help you to find your right advisor, the right department, and the environment where you can really thrive. I think that I bring over a decade of experience in PL and formal methods, more than 7 years in teaching and mentoring students. I've been a SIGPlan M mentor since this started. And of course, I'm a host of this podcast for about 5 years now. And this gives me a unique chance to connect with many researchers across the field and know what a lot of people are working on. So I thought about starting this project to really assist some people. If you're thinking about grad school this year, or you know someone who is, now is the time to get started and apply. You can find all the details and book a free introductory session at typetheoryforall.com/mentorship. And also, if you want to just learn, got started in type theory and programming languages, I also have a tutoring service on, like learning Rock, learning some programming languages fundamentals. You can find more details on typetheoryforall.com/mentorship as well. So without further ado, let's get into this conversation. All right, welcome everyone to one more episode of the Type Theory for All podcast. This is a very special episode with someone very special, but before I present him, I want to say hi to our newly married handsome man, Dan Plokin. Welcome to the show, man.
Thank you. Thank you for having me all these years.
I'm always so glad to have you over. You always come up with some really, really cool questions and really assist me over. So I really appreciate you, man.
I appreciate you too, Pedro. Thank you for everything you're doing for our community as an edutainer.
Well, someone who has done so much more for our community and for the research that happens in programming languages is here with us today, and nobody of us can even closely compete with Philip Wadler. Welcome to the show, Philip. Thank you so much for being here.
Thank you. I think everybody has something to contribute. I'm very uncomfortable with the way you characterize that.
You have a very long career, and you have contributed with some really incredible...
I'm older than you. Yes, that's true. I can accept that.
Okay. Well, we're going to be talking about some very key contributions you've had that I'm very keen to hear the stories behind. And but, I usually like to really get to know the person behind the research. Not only, there is the research, but usually there's a whole life. There's a lot happening that goes unsaid, and I would like to have a better glimpse of who you are, as an academic, as a researcher. And the way I usually start these interviews is by asking, how was your early coming out of undergrad? How was your first contact with PL research? what made you interested in pursuing this kind of career?
Well, I guess I'm fortunate enough to have had a lot of exposure to research while I was still an undergrad. So I was very lucky. I got into Stanford. I think if I tried to apply now, I'm not sure I would get in. But back then, maybe it was a little bit easier. And so this meant that I got taught data structures by Donald Knuth. My first job was with Vint Cerf. I think I wrote the first game that you played over the internet. It was a version of Space Wars.
Wow.
And I learned Lisp from John McCarthy. So that really got me set up for doing research in functional programming. I realized that when I went to graduate school. There were all these things my colleagues didn't know that I knew. It was because I sat in McCarthy's Lisp class and he explained it all to us.
How was it like to be in this scenery? You know, like when you're in the middle of it, you don't realize how, I don't know, like how important. Did you realize how important these people were for our, you know, like for computer science back then?
Well, I knew that I was fortunate to be working with a lot of Turing Award winners, right? Knuth already had his Turing Award.
Okay.
McCarthy already had his Turing Award. Cerf didn't yet. But it, the internet was clearly even back then pretty important. I remember one day using the bulletin boards, which had lots of interesting messages on them, and this was pre-internet. I was looking at the bulletin boards, and I suddenly thought, "Oh, these are going to have advertisements on them one day." I didn't know how they were going to have advertisements on them. I suddenly thought there will be advertisements on this, and if I'd only known how, maybe I'd be much better off today.
I was wondering if, in retrospect, you kind of are there kind of secrets that you learned from folks like Cerf and McCarthy that you still have now that like a lot of people don't know, or can you recall specific things that other people didn't know at the time that you kind of got from proximity to those people?
Yeah, you learn little tiny bits of the history, like McCarthy told lots of interesting stories about the development of Lisp. And he told the story about they had wanted to use syntax for Lisp. And then one of his students came up with this idea of, well, Lisp is manipulating S expressions. Just to get started, why don't we represent Lisp as S expressions? And then he pointed out, that they never got past that point. And then one of the students said, oh, we should have an S expression that stands for a function. And McCarthy had studied under Alonzo Church. So he went back and looked at his notes and came back and told them, we'll call it lambda. And I'm told, not by McCarthy, but history records that Church was not a particularly inspiring lecturer. And I think all he picked up from the notes was the syntax, which is a shame because, when I was young, everybody was worried about this thing called the fun arc problem. And the fun arc problem was that if you passed your function into a different context, since they were using dynamic binding, it would behave differently. Or if you passed a function into a different context, it would behave differently. And there's this huge issue about what are we going to do about the fun arc problem? And I remember reading lots of papers about the fun arc problem. And it turned out what the fun arc problem really was that Lisp used dynamic binding instead of static binding. And I remember seeing this lecture by Hewitt when they just come up with Scheme. He was visiting at Stanford, and this was like my last year as an undergraduate. And then he explained about, you need static binding instead. I'm not sure I actually followed it at the time, but it was a very important lecture for me because he explained about lambda calculus, which I I'd heard the term lambda, but not the term lambda calculus. And so that got me moving in the right direction in terms of what I would then read and study.
I think actually, so your point is kind of that one of the benefits of studying under these people was that you got kind of a historical perspective, and I think that that's a big thing that I get out of your writing is that I don't know, you seem to be kind of very informed by a lot of different historical kind of developments. Like for example, like you're familiar with like logic and stuff like that. And I guess maybe that's more of a comment than a question.
Well, I think, maybe one thing that I absorbed from these people was the importance of history. But I just sort of always took that for granted. The one place I can remember learning about the importance of history is reading Feynman's memoirs. I can't remember which of the two Feynman books it's in. You know the two books I'm talking about.
I know the one that he talks a lot about science and religion. I was reading these days. Really good book. The other
There's
one.
Surely You're Joking, Mr. Feynman. They weren't written by him, right? They were written by a colleague of his who interviewed him. And there's Surely You're Joking, Mr. Feynman, and What Do You Care What Other People Think?
Yeah.
And in one of those, he talks about his first wife getting horribly ill. And the way he understood what was going on was by reading the first papers about the illness, which had things in them that weren't in the other papers. And then when I went back and did things like read Genson's original paper on logic, the one in which he introduces natural deduction and introduces sequent calculus, or in other words, the two main forms of logic that we use today. He also introduces the upside-down A for all in that paper.
By the way, they
had for all before that. For all was about 50 years old then, but he introduced the symbol. They had the backward Z, but for all, they just wrote the variable in parentheses. And he said, oh. So there are lots of important things in this one paper.
Wow.
But in particular, from that paper, I understood why cut elimination was important, which I did not understand from reading the later stuff.
Which is?
Why is cut elimination important?
Yeah, save us from having to read the paper.
No. that would not be saving you anything. No, you want to go and read the paper. No, but the what cut elimination was about was showing that if you did a proof with intermediate results in it, that you could turn it into a proof without the intermediate results. So let's say I'm proving something about numbers and I use some geometric concepts in the proof, but all the hypotheses and conclusions are about numbers. Then I can turn that into a proof that just talks about numbers and never talks about geometry.
Mm-hmm.
Right, that's pretty important, isn't it?
Yeah.
Oh, yeah. I sometimes find it a little frustrating that I feel like my generation doesn't go back enough to read the original papers and the original results. I'm not sure why or how. Would you be able to pinpoint what exactly is the importance of going back and like being in contact with the initial results and the main authors and the original stories here?
So if you're not doing it enough, then that means there's something wrong with the way you were educated. And maybe all this exposure to other mediums like video, which I tend to avoid when I can, probably just because I didn't grow up with it in the same way you did. But I think that there's no substitute for going back and reading the original papers. And, sometimes I try to do it would be very hard. Reading works on logic earlier than Genson can be quite difficult. Or at least I find it quite difficult. But whenever you can, at least going back to the original is hugely valuable, I think. Because, this is so one thing that's important to understand about in the history of science, and I think many people in computing just fail to pick up on is the importance of communication. Right? Your goal is to communicate to other people. And so, the original paper is communicating why this thing is important.
Mhm.
And later papers may not do that so well because it was already done in the first paper. So this is old work now and you don't do it.
Mhm.
But communication is vastly important. And I found often that looking at the original papers is a very good way of understanding what's going on. And, also you can learn interesting things like they were interested in this because of this problem, which we don't consider a problem anymore,
Right.
but now we use it for this other thing.
You say that the goal of science is to kind of communicate with other people. My goal going into science was to sit in a small room and think about things and not talk to anybody. But then I kind of gradually expanded into the idea that maybe it would be nice if some other people kind of knew what I was doing. Did you
But
always
did you
start
just
off with
think, or did you build on top of what everybody else had done?
Right. I would read what people did, and then
So
I
they
would
communicate to you.
Yeah, exactly. Well, so
and
this
then
is
if you
kind of my
don't communicate
question.
on to other people, you're not discharging your part of the chain. You're breaking the chain. You don't want to do that.
But I think a lot of like PhD students, when they start out, they kind of, we tend to be like pretty introverted or something. We like to think about stuff. Did you start out that way too, or were you always kind of prioritizing communication in the way that you do now?
So, yeah, I was a lonely nerd, just like everybody else. But I wasn't aware of thinking very differently from people around me at the time. But, maybe that's because I was surrounded by people like Don Knuth and John McCarthy, who are very good at communicating. And so maybe I just absorbed that from them. But if people are in, so yeah, it sometimes feels that the goals in computing are much more oriented around writing code than around writing prose, at least for some people. And if what you want to do is ultimately you're going to communicate more to the world by communicating with other people, because then they can build on your work. So, if you're on your own, you're never going to get that much done. The way you get things done is by communicating to other people, and then they can build on what you've done. So the things that I've done that have turned out to have some value, like type classes and monads, if it was just me doing it, that would have been pretty useless. The important thing I did with type classes, for instance, was make them simple enough that other people could pick them up and then do things with them. But the most important thing I did was I enabled Mark Jones, because my original type classes were all first order, and he figured out how to make them higher order, which I would have thought was impossible because our type systems were based on unification, and higher order unification is known to be an unsolvable problem. But despite that, he made it all work in a useful way.
What were you developing? Like, where did the idea of type classes come from? What's the story there?
Knew that, various places, overloading is really helpful, right? You want plus to work on both integers and floats. Or times. So you want to be able to define the square of x as x times x. But then, oh wait, which times is that? And what if you takes a function that takes in three numbers and returns three squares? That's actually defining 8 functions, right? Because each of those could be an integer and a float. So that was a problem. And type classes were a way that would solve that problem.
Did you So this was in the context of Haskell already, right?
They came up in the context of Haskell. That's correct. So we were designing Haskell, and the idea is, okay, we're doing a lazy functional language. Let's use the standard solution for this problem. Oh, wait, there isn't one.
Back then, did you already had an idea of how it would how it would work together with the notion of modules and how it was being done in Haskell? Because nowadays it's not that they're kind of like dual, like not dual, but you can implement modules with type classes kind of, and vice versa, right? What I'm getting at the heart here is this contention between Haskell and ML, where ML, they really focus on doing modules extremely well, and Haskell have really good type classes, right? Did you already have an idea of this contention when you were coming up with this notion?
No, but Dave McQueen wrote a very nice paper early on making exactly the contrast that you're making. No, I just wanted to cope with overload. And the fact that then lent itself to algebra and lent itself to reading, to reasoning was just very fortunate. And I recognized that early on. So the very first paper on type classes says, by the way, you can put comments in the type class that correspond to the properties that you want your operators to satisfy. And that turned out to be a good insight. So that's why type classes then showed up in every single proof assistant, because they've worked with this very well.
But you talk about coming up with type classes as if, you pluck them from the ether. But just after talking about the importance of kind of taking things from history, do you think there was any kind of
inspiration, maybe?
Inspiration for that, or did you pluck it from the ether?
Well, it was clearly an application of what back then we all called Curry-Howard, and now I call propositions as types. So this notion that you can view an implication as a function. And so there was something in type classes that was written as an implication. If A belongs to the numeric class, then this function will take an A to an A. But it'll only do this for A's that belong to the numeric class. So you had an implication there. But that turned into a function, which is, give me the implementation you have in mind for the numeric class. So, if A is int, give me the numeric operations on int. If it's float, give me the numeric operations on float. So that was the key idea. So that just came from the work people had been doing with Curry-Howard, which went back, I didn't realize it then, but went back at least to the 1930s and the intuitionists.
You didn't realize it then. What was your view of it back then?
Oh, so when I started as a research assistant at Oxford, they sent us all down to London for a couple of days because these people had come across from Sweden and they were explaining this thing called type theory. So that was when I first heard about Curry-Howard, and I just thought, oh, this is a bizarre, funny coincidence. And when I first heard about it, I just thought, oh, this is a funny coincidence. I didn't realize that would be the basis for my entire research career.
And that was people from Martin Luff's group who were coming down? Yeah, okay.
So you mentioned that nowadays you prefer saying propositions as types, right? So would you say that you're trying to use a better name here so that it's more have better intuition, so it's easier to communicate?
Oh, so the reason for changing the name is that lots of people object and they say, well, you shouldn't attribute it to Curry and Howard. You should attribute it to people like De Bruyn, who had the same idea independently. or to Brauer, Heiting, and Kolmogorov, who had very similar ideas. Right, so there's some people saying call it after the Brun. There are other people saying calling it after Brauer, Heiting, and Kolmogorov. There are people saying call it after Curry Howard. So I just pick propositions as types so that you're not attributing it to one of those people and not another.
Gotcha. And it seems to me that
it was to get out people arguing with me.
It seems very important. Like I've noticed how important it is for you, how you value proper attribution for ideas for people. And even here, that's exactly what you're getting at, right? Like attributing the work people are doing correctly to them, right?
Yes. I mean, what we're doing is building upon other people's work. If you hide that, then the other people's work is out of focus and you won't understand what you're working from. You won't get the most benefit out of other people's work. And that's why I suggest going back and reading the original papers as well, to get the benefit that the original developers put in there. And, I would use polymorphism for a long time before I understood that System F was the thing that encapsulated polymorphism. And then I got much more effective at my job once I learned about System F. But if right, and some of that happened. So I'd read Milner's original paper, but Milner was working independently of the work going on at the same time on System F. I read Reynolds' original paper, but he didn't know about Girard's work back then. He didn't find out about it for a while. So it took me a while to learn about the stuff that I ought to know. So I was introduced to it by Jan Fairbairn. So I'm very grateful to Jan for explaining this bit of the history to me that I didn't know and should have known. So, fortunately for me, he was going around telling us all, wait, you should know this other stuff as well. Just like fortunately for me, I bumped into Carl Jud, who said, oh, you should understand about Church's lambda calculus, which I hadn't known about before. I just knew the name lambda.
Uh-huh. Well, a lot of our listeners are going to be kind of at the start of their kind of learning journey for this type of stuff. When you were teaching, did you encourage people to go directly into the primary source, like from day one, or how do you kind of recommend that people ease their way into stuff like that? Because, like you said, it can be quite difficult. And
so when I'm teaching Haskell to first-year students, I don't say go off and read all these original papers, but I do refer to all the people whose work we're building off of. So, when we introduce induction, I do mention, this goes back to this work in the 1800s. So I try to encourage them to understand there is a historical context.
And it's something that kind of just organically you end up finding your way back to the primary source. There isn't really it's definitely not like a day one type of thing that you should be doing. It's not really clear when you should do it. Just what I guess I don't know what at what point is somebody ready to really dive into the primary source, something like the Jensen or the System F, for example?
If you're teaching a first-year class, most of those students are not going to become researchers. They're just going to use this stuff.
Mm-hmm.
I would jump up and down and tell the students lots of things, but I wouldn't jump up and down and tell them, go and read the original sources, among other things, because I knew most of them wouldn't. And it's not appropriate for most of them. But maybe I should have stressed more, when you finally, build something, know what you're building upon. Go back and read the originals so that you can build appropriately. Maybe I did not distill that lesson as clearly as I should.
I think one of the things Dan is getting at is, for example, when I was in undergrad, I kept listening how important was the work of Russell and the Principia Mathematica. So I went to the library and I I got the three huge books. I opened the first page. I literally cannot understand even what is the symbols there, because it's completely different set of symbols, right? And I think today with ChatGPT would have been easier. Maybe, I don't know, but like how do you ease your like? I think today I wouldn't be able to read Russell's work still, because like I still do not understand what are the like, maybe even implication is like actually set, like we use like the set like the curly thing there, like for implication, and that was not clear, for example. Um anyways, how do you
Yeah, so Principia Mathematica is indeed very difficult to pick up and read. But there are other things by Russell. They're very easy to pick up and read. So Russell's original paper on type theory, have you ever read that?
not that one?
So the second half of it, where he actually introduces type theory, is unreadable. But the first half of it is extremely readable. He just goes through a bunch of paradoxes that lead you to understand why you need type theory.
Mm.
So he talks about right. There's a word heterological that refers to words that I can't remember which way around it is. But there's a word for words that describe themselves, and there are words for words that don't describe themselves. And then, is that word, let's say it's heterological. Is heterological? And they point out this is just like the question of there's a village where the barber shaves everybody who doesn't shave themselves. Who shaves the barber? Right, and these are all variants of Russell's paradox.
Is it the word, is it predicative?
That's where the words predicative and impredicative show up, which I used to be really scared of for a long time before I finally read some things that began to explain them in a useful way. But I've spent many ages being scared of type theory, scared of predicative and impredicative, and so on. And eventually they became friends instead of scary things. So I guess, if you're scared of something, the answer is just hang in there. And as you point out, now you've got much better resources. ChatGPT or other models like that can do a lot for helping you to navigate and explaining things to you. But yeah, one of the things that you should do then when you're asking a large language model about this is ask it, which things should I go off and read now? Right. And for instance, right, just going into Principia Mathematica is very difficult, but there were lots of papers that they wrote then which are much more accessible. It would take a long time to bring all that in. No, I have not taken the huge amount of time to do that. But I've spent a lot of time doing other stuff, reading other things by Russell, reading Russell's autobiography. So there are other things that come in that can give you a way in, even if the original thing itself seems impenetrable.
Mm-hmm. Speaking of kind of diving into like a wide and varied sources, is that kind of how you got into linear logic? Was that you were like reading through logic journals and you found Girard's work, or was it through something else?
The way I got into it was I was serving as a postdoc at Chalmers in Göteborg, in Gothenburg in Sweden. And they had a reading group every week. And they were going through things like Girard's original Semantics for this, which was quite detailed, quite hard for me to follow. But they were saying this is all very important. And so eventually, I think not by reading the original, but by reading Lafont's explanation, I began to understand what was going on. And then did this bit of, I understand now. I want to explain to other people. which is an enthusiasm that I think I learned from Donald Knuth. I remember him talking to us in class about, combinatorics was very hard, but now that I understand it, I want to explain it to other people. And then he went off and wrote volume 4 of Knuth, which is about combinatorics.
Was it the same thing with monads for you?
Yeah, I guess so, because, right, it was Eugenio Moggi's idea.
How did you come across it?
And my adaptation of it was a very slight twist on what he was already doing.
How did you come across his
You
work?
were on his...
So I was a young faculty member at Glasgow at the time, and various people went off to LIX. I didn't go off to LIX that year, but when they came back, I said, so were there any interesting papers? And they said, yeah, everybody seemed to like this thing on monads. I went, monad? Oh, that sounds very scary. But I read Eugenio's paper, which was very straightforward. I was at Glasgow at the time. Eugenio was at Edinburgh at the time. And I got on a train and went across the country and spoke to him. And fairly quickly cottoned on that, this is a useful way for structuring programs. So he'd used it for structuring denotational semantics. But denotational semantics is basically just an interpreter written in a functional language. And so the first papers I wrote were basically explaining, or one of the early papers I wrote, the first tutorial I wrote was, okay, you could use this to write a bunch of different interpreters. I just went through a bunch of concrete examples. So you want an interpreter. I picked the simplest interpreter I could, one that does division. And then I said, okay, you want to count the number of division operations. So normally you do that by incrementing something. So what's the equivalent that we're going to do here? It was passing some state around, which was the number. In this case, the state was the number of divide operations that you'd seen so far. Or what if you want to do a trace? Well, that's building up an output. So you have an output from one part and output from the other part, and you concatenate them. Or you want to give an error message when you divide by 0 rather than exploding. And so you pass it around, either, yep, this is an answer, or this is an error message. And so those are the 3 concrete examples. So, each of those is easy to do. You just completely rewrite the program. And the point was, here's an easy way to do it where you don't have to completely rewrite the program.
There's one thing that you glossed over that it took me a very long time to kind of see the connection, was that the connection between denotational semantics and interpreters for functional languages. Could you elaborate a little bit on that for some of our listeners?
They're the same thing.
Well, I mean, they're phrased in such different ways. You never see it talked about as an interpreter for a functional language. You just see you're denoting it as a mathematical. Well, I think it's denoted as a mathematical object, and I forget that there's this connection actually to, I guess, a lambda term is a program, and it's also a mathematical object. So I guess that's the whole connection. But it took me 10 years to figure this out. It was
John Reynolds wrote some really great papers about all this stuff, right? So he went and talked to the people developing denotational semantics, and then wrote a tutorial on continuations. And if you tried to approach it through what the semanticists were doing, it all looked like very complicated mathematics. And then John Reynolds explained it just as a very simple technique for writing your code. So you need to find your John Reynolds. If you haven't read John Reynolds, go off and read John Reynolds, and then all the things that you thought were very unclear will become obvious, like the relationship between denotational semantics and interpreters. Have you read John Reynolds?
Curious. Oh, bits and pieces,
Okay.
But so another thing that I was curious was, so you read Eugenio Moggi's paper and you went off to see him, and it wasn't until you actually met him and talked with him that you kind of developed these ideas. What was your kind of idea from reading the paper, and I'm kind of interested in what what comes out of talking to people? What came out of that particular conversation that you didn't get through just reading and writing?
I don't have any recollection of having a sudden extra insight from talking to Eugenio. So he'd written it all down very clearly. And everything important I actually picked up out of his papers. My main Eugenio story is actually from a few years later. I'd written some of the papers on monads, and I was trying to explain them to so there was a working group for functional programmers, working group 2.8, which still exists. And we had a meeting of this, and I was explaining some of the work that I had done with monads. And at one point, it'd been around for a while. So I began by saying, okay, who here already understands this? And a couple of people in the audience raised their hand, but most didn't. So I knew what level to pitch the talk at. But when Eugenio was in the audience, and I said, who here understands monads? He sort of half raised his hand like this.
Was it?
Do you think it was because he's shy or because he didn't know?
No,
He's very humble.
I think that was because his notion of knowledge was about something much deeper. And, he understood monads much more deeply than I did. But he, unlike me, knew what there was to know that he didn't know. I think that's what he was referring to. So that he understood one aspect of them, but he understood that there were other aspects that he didn't know very well. I don't recall where that particular meeting was. I'd have to go back and look in the records.
Okay. So something that strikes me is that this is a theme that all the listeners will notice that I always bring up every now and then. I bring it up, which is this overarching feeling that I have that sometimes it feels that the cool research in programming languages has already been done in the 60s, in the 70s, in the 80s. And we're kind of scrapping the pieces here for applications these days. And the papers nowadays is like a huge pile of extremely technical details that is like sometimes feels that we're not touching, like this mathematical beauty and essence that it used to have back then. Do you have the same feeling, or what are your view in this?
Well, all those poor physicists today, Isaac Newton got all the literally low-hanging fruit. And, what are they supposed to do? But that's not true. Turns out there's lots of interesting stuff to do in physics today. So, yeah, all the people in the 30s and the 60s got a lot of low-hanging fruit. But that just opens up what there is next. And, there's been a lot of incredibly important groundbreaking work done in our field. So, you might say, oh, well, Robin Miller already did pi calculus. What's left for me to do? But I think actually that, there will be somebody in computing. There will be people in computing who are remembered as well as Newton. So obviously Turing's going to be one of these. He's on the 50-pound note already. But I don't think it'll just be Turing. And I think the really important and famous discoveries haven't been made yet. I think you guys are the ones who are going to make them. I think because of just what you said, right? These days, it just feels all like playing with a bunch of ticker toys rather than like doing mathematics. Well, that's wrong. Who's going to figure out how to turn it back into mathematics again?
That's a fair point. We don't know how LLMs work actually in the mathematical model, right? For example.
Well, that's AI, which is a different discipline. What I do used to be AI, right? I learned it from John McCarthy, who came up with the name AI. But if you if you take concurrency, for instance, there are loads and loads of different approaches. Which one is best? Which one is canonical? Right? For basic abstraction, lambda calculus clearly dominates, right? That's the approach we all use. But there's no real equivalent of that for concurrency. There are some, various popular techniques. But I don't think there is an understood canonical approach yet. That's what I was hoping linear logic would lead me to, but I realized linear logic is good for the bits of concurrency where you don't need concurrency.
That's
right?
funny.
Linear logic guarantees there's no race conditions. Well, that's great, but sometimes we need race conditions. So how do you fit those in there?
Mhm.
And I still think that's not known, right? And it took me a while to understand this, right? But lambda calculus is basically about simply typed lambda calculus, which is kind of interesting because that always terminates. That's the bit for which the halting problem is solved trivially. And it means, you can't do general recursion here. But then you can add the fixed point combinator. It's still well typed. So the fact that you can add the fixed point combinator, which throws away this very important property of always terminating, but adds this important property, but now you can do general recursion, and you still keep types. Who would have thought that? And this is bizarre, right? Because, the whole point is Curry-Howard, it's all based on logic. What does the fixed point combinator correspond to in logic?
Are there any theories?
Yeah, I think
Paradox.
Yeah.
The fixed point combinator, right, trivially lets you prove any theorem. It corresponds to paradox.
So
Who would have
logically,
thought
if you apply paradox
would be important in practice.
That paradox applied to a type system would give you still a sound type system. That's actually very strange. But so that's kind of like a deep question, I guess. Like, what is kind of the meaning of this type of stuff?
And so there's fixed point combinator let you suddenly bring in all this stuff that you'd thrown out that you need without breaking the system. Linear logic lets you guarantee that there's no race conditions. Yay! But sometimes I need race conditions. Right? I'm selling tickets, and that there's going to be a race between the last two people to buy an available ticket. Right? So sometimes having race conditions is really important. Okay, is there one thing that I can add to linear logic that's going to give me race conditions? Not known.
Have you seen any kind of promising directions in that?
There's a conjecture that you have what's called a compact system, where two of the operators of linear logic become the same operator. Tensor and par collapse to the same operator, which is kind of bizarre because tensor is and par is or. It might be that if you collapse those, that then you can do it. But there's been some work written suggesting this, and I've suggested it, but it's not as solid as it needs to be useful.
But you have a lot of faith that the solution...
An open problem.
Yeah. You have a lot of faith that the solution will eventually come from logic. It must be kind of tied together.
It would be very nice if it came from logic. It seems quite likely that whatever comes along would have interesting correspondences to logic. But I have a much stronger conviction that there will be a solution than that it will come from logic. Maybe there will be a new solution and the new logic will come from that. I don't know. But I'm sure that there will be deep insights into these things that will make them much more usable. Like a lot of the work these days is around effect systems. But again, just like with concurrency, there are too many different approaches to this. And we don't know what the canonical approach is. And the approaches that exist are kind of complicated. We don't know what the simple approaches. I'm sure something better will come along. I'm sure one of you guys is going to figure it out.
I don't think it's going to be either of us, but
Hey, man, you're turning me under
Well,
the
by one
bus
of you
here.
guys, I meant everybody listening to this podcast.
yeah, it's our listeners for sure. I think definitely it would come from one of our listeners, and I think we should get some credit for that. We should be in at least the related work.
That'd be awesome.
But so you talked about one of the issues with linear logic is it's good for all the concurrency when you don't need concurrency. Are there other kinds of things in your past work, like for example type classes or monads, that the way that you envisioned how things would go back then has been kind of superseded by new work now that you think is maybe better in most ways or in some ways?
It never occurred to me just how widely type classes would spread and how many different uses they would get. I was really just about, okay, this seems a nice approach to deal with these overloading issues, but it's turned out to be wildly more useful than that. I didn't even think it would be useful for monads when I did it because I thought it was first order. And then Mark Jones figured out how to make it higher order, which, is one of the reasons monads succeeded, because then they fit in to the type class mechanism.
Yeah, I wonder how many things like it's a great idea, but it was missing the other half that would have kind of made it work together. It's really monads and type classes together that made that effective. But so those are things that where your work has been kind of more successful than you expected. But I'm wondering if there are kind of other developments that you think kind of beat out or just kind of more elegantly expressed what you were trying to express back then. Like I'm thinking, for example, of like algebraic effects and handlers.
Oh, well,
which,
clearly
seem to
algebraic
be like
effects and handlers will supersede monads. Yes, absolutely.
Okay.
Eventually,
100%.
when they figure out what to do.
Meaning?
Well, meaning the various problems I just alluded to. But the systems right now are too complicated.
Mm-hmm.
But, right. Algebraic, one of the things we were trying to do is combine monads. There was lots of papers about how to do that. And it's again quite messy and tricky. And the whole point of algebraic effects is they're a subset of what you can do with a monad, but those combine very neatly. And it turns out that algebraic effects plus continuations, which are an effect but not an algebraic effect, but those two things together cover pretty much everything you need. So all of the effect systems out there have continuations just built into the idea. And yeah, no, I have no doubt whatsoever that monads will get superseded by that when they work out, when we finally work out the right way to do it. I think we've not finally worked out the right way to do it yet.
Speaking of algebraic effects, that's actually a great example of something where I tried to go back to the primary source, like the work by Plotkin and Power, and I spent a whole summer I didn't get anything out of it because I was just so overwhelmed with all the math and the category theory. I was totally out of my depth. Do you think that these days that we have kind of better secondary source references that can give people the context to go back to that primary source? Or do you think that maybe I just needed to do, I needed to read Audi's book on category theory and then get into that and start properly?
Whose book?
I think Steve Audi, he did category theory. Yeah.
So the way I learned category theory is by reading McLean's book, Categories for the Working Mathematician, which is how most people originally learned category theory.
But it's hard for kind of people with a non-pure math background like what you.
No, it's impossible because it's not written.
Yeah, okay.
It's not written for us. It's written for mathematicians. But what you do is you just ignore the motivation sections, which give lots of examples based on mathematics that you and I won't know, and then just read the formal development. It's fine. But then you need to get the motivation from elsewhere. So Benjamin Pierce, back when he was a graduate student, wrote an introductory book on category theory, which doesn't do the development as neatly as McLean, but gives you all the motivation. So just read Pierce and then read McLean.
Okay, perfect.
I haven't read
And
Hourly,
then-
so I don't know how that compares. How does it compare?
I found it, kind of. I've always found I've gotten stuck on category theory. I'm a terrible person to ask. I found it like hard to tell if my proofs were correct. Even, there's something about category theory that I just didn't find the right book, and maybe Pierce's book is the right thing. I think that's kind of the situation for a lot of people.
I had the same problem with Pierce's book because since there was nobody to kind of like get us unstuck in our working group, so we would spend most of our time discussing if the proof was correct instead of like making progress. That was very frustrating.
Right. So if you're not sure if you've got correct proof or not, sounds like maybe you want to work with a proof assistant.
Yeah.
And a framework for that does category theory.
Yeah.
I think that could be a really useful tool for
I'm not sure which one to recommend. So every time somebody talks about formalizing category theory, they go, oh, the existing formalization makes this, and this very difficult. So, again, sometime in the future, somebody's going to write down a formalization of category theory that's easy to use. But we're not there yet.
Looking back into your work,
but basically, if you're having trouble absorbing something, I think the important thing is to find a different way of getting it. Either decide it's not for me now, or find somebody that does something different. Like homotopy type theory is clearly really important, but it's also clearly, for me, really hard to absorb most of the things that have been written. So I'm just waiting for somebody to write something that's a better way in.
What did you find difficult? I'm surprised that you would get stuck on anything.
It's difficult enough I can't even explain to you what was difficult.
Looking back into all your work, Philip.
I can tell you what makes me think it will be worth understanding eventually, which is when I saw the proof of extensionality done in cubical agda. It's like, oh, I don't need to take extensionality as an axiom anymore. I can prove it. That's really nice.
Which, for a little bit of background, maybe for what is extensionality?
Extensionality is just a definition of equality for functions. It says two functions f and g are equal. What does that mean? It means that for every x, f of x and g of x give you the same answer. So for every x, f of x and g of x give you the same answer, then we're going to say f is equal to g. That's another way of saying the only thing that counts about a function is how it acts on its argument.
And normally you take that as an axiom, but with cubical agda, you can actually prove it. Is there is a key idea to the proof that how homotopy type theory makes that possible?
Well, homotopy type theory is all about equality. So it's not surprising that it gives you enough flexibility to then prove that. But no, I'm not going to try to explain the idea behind the proof because I don't think I understand it well enough to explain it in a way that would be useful to other people.
So this also means that homotopy type theory throws I cannot reason about performance of programs, for example, because it's kind of like merge sort and insertion sort would be the same functions in cubic, right?
Right, exactly. So if you say this is what it means for things to be equal, you can't distinguish different algorithms with different time complexities because they're just treated as the same thing. Okay. So this kind of equality might be too coarse for certain purposes.
Yeah. But moving the subject a little bit, if you look back into your career and your research, is there any particular piece of research you've done that you think didn't receive enough love? That wasn't as popular as say Monads and Type Classes, but you still think would be very very good piece of research you've done.
But there are various things that I did that I thought were quite interesting that had not been picked up on and carried forward in the way that those were. And they were very nice, and they threw a celebration for me when I was 60 years old. So I got a little Festschrift, very nice book. And all of this. They did a huge number of nice things, and I paid it back by giving a talk. They asked me to give a talk at the end of it. I gave a talk saying, here are these other ideas I had that I thought were really nice that nobody's followed up on yet. Maybe one of you would like to follow up on.
Do you remember on the top of your
I can't
head?
remember all the ideas
Right.
I discussed. I remember one of them would have been the work I did on classical logic. So there's what Curry Howard tells us is that lambda calculus corresponds to intuitionistic logic. And then there are various answers about, well, what corresponds to classical logic? And some using classical natural deduction and some using classical sequent logic. And there's some quite nice work by Eberlin and others on classical sequent logic, but their main operator is implication. But in classical logic, right, implication isn't very interesting. It's interesting, but it's not the basis. The basis is and or because those are dual to each other. So I took this other work that was based on implication as a primitive and turned it into something that was based on and or as primitives. And that worked out very neatly. And I still think people might be able to pick that up and do something useful with it. So that's something I did that I'm quite proud of, but hasn't had a very big impact.
There's one question here that I've noticed these days that a lot of undergraduate programs doesn't even mention proposition as types or Curry Howard at all in their curriculum. A lot of students come out not even hearing about lambda calculus and any kind of programming languages research. Do you think that's kind of like? Do you think that's bad? Do you think that's natural for where CS education is going? I feel very. I personally, I'll give you that. I personally, I feel that it's very saddening because like propositions as types is one of the most beautiful things in computer science for me. Maybe only loses for the halting problem itself. Maybe I don't know. But I personally got very upset about this. And you have a lot of you've done a lot of teaching. What are your opinions about this? How do you see it?
Well, I don't teach propositions as types to my first-year students. I teach it to my fourth-year students.
Mm-hmm.
And not all the students taking computing take my fourth-year class, just a tiny fraction. So I certainly haven't. You wouldn't be happy with the way I teach because I don't teach it to everybody. Maybe that's a mistake, but I'm not sure in the current state of things that everybody wants to know about dependent types. Again, I'm hoping that in some, if you look 50 years down the road, I hope everybody will learn about dependent types. But that will partly be because we'll have much better systems that are easier to use. And some of that may come from AI, but I'm guessing the key elements of that will not come from AI. They'll come from other insights about how to set up these systems in nice ways.
What are your views of AI in not only in our field but in computer science itself? There's a lot going on right now. Do you think it's really changing that much our relationship with how we do programs, we reason about programs, we do research, we write? What are your views?
Right, there's a lot of hype about AI now, and that's coming from these very big tech companies. And there are a lot of problems with it. And if you look at, there's just a lot of problems with the big tech companies that we're largely not addressing. Right, they've managed pretty much to avoid regulation. And if you think about, what would driving be like if we didn't have regulation? What would eating food be like or taking medicine be like if we didn't have regulation? But for computing, which is a huge part of everybody's life, we basically have no regulation. So I think that's an enormous problem. And then the systems that exist are, right, there are lots of problems around the edge of them that haven't been tackled, like the problems with deep fakes, the problems with, right, there's bias built into lots of these systems because of poor training data. That was just in the news at the Notting Hill Festival in the UK. They wanted to use facial recognition for people going in to see if any of them were known criminals. And this is in part of the Black community. It's well known that facial recognition has problems because of the training data. It's often biased. So there was a lot of discussion of this in the news, with some people saying, oh yeah, if you set the thresholds here, it's biased, but if you set the thresholds higher, then it's not biased, and we're setting them higher. And then somebody else who understands this stuff came and said, well, yes, but the paper that says that it's not biased is based on a tiny amount of data, and you shouldn't believe that. So there's still a lot of controversy going on about resolving these very basic problems. And now all of a sudden everybody says, look at all these things ChatGPT can do, or Gemini can do, or Claude can do, or whatever. Obviously we're bound to have human level intelligence any day now. And I think that that's just fundamentally either misunderstanding or misrepresenting. I think you get some of each of how these systems work. It seems pretty clear that we won't get anything approaching human level intelligence until there are a few more breakthroughs, and we don't know what those are going to be. And some people say, yeah, but we just had a big breakthrough, so we'll have another one soon. And I'm of the form, well, there's this thing called regression to the mean. If you've just had something that's better than normal progress, what you should expect to see is the level of progress get slower again, because it's been above the normal, so it should return to normal, and it'll get slower again. But all the valuations of these AI companies are not based on that idea. They're based on the idea that it will get faster and faster and improve very rapidly. And I chose to divest myself of that part of the stock market, because I think they will eventually find out that that's not true.
Mm-hmm.
What do you think our kind of moral, ethical obligations are as like computer scientists, as software engineers to this? Do we just wait for regulation, or should we start
we have
reading
to
critical theory?
argue for regulation. I mean, everybody has to argue for regulation. We have a special place in arguing for regulation because we're the people doing it.
Mm-hmm.
So we need to explain, for instance, there's very little regulation over code, and we're all in a good position to explain why maybe more regulation over code would be a very helpful thing to have.
Mm-hmm. Should we be teaching this in schools, do you think?
Yes.
Yeah. How? Is it like a course, ethics and computer science? Is it something that I can stick in my programming languages course?
So at Edinburgh, we have such a course, yes, which I taught for a while. And all the students hated it.
How's the curriculum look like?
Because they, part of my course is even just, here's how to write clearly. And they all go, oh, I know everything I need to know about writing.
Oh, no.
And when I read what they
We'll talk about that.
What they write, I know, no, that's not the case. You don't know everything you need to know about writing.
Yeah. But what was your ethics curriculum
everything
like?
else? But they, most students, it seems to would rather not think about these issues. So if you try to teach them about it, they just say, "No, we just teach us how the AI works, please."
Mm-hmm. So what was in your ethics course? And I mean, if the students didn't like it, does that kind of mean that the course was a failure in a sense, like that it didn't really get through to people? I know that, when you try to introduce...
It means I was a failure, yes.
Talk more about this. And what was in the course? What do you think could be done better? How do we do this better?
Oh, this was a while back. I think that I'd do a bad job if I tried to summarize what was in the course, but it was a course that I picked up, and I did not look carefully at changing the curriculum because I was focused on other things. Maybe So recently I've spent a lot of time trying to talk to the general public about AI. So now I put more of my time into that sort of thing. Maybe it would have been a good idea to put more into it then and try to ensure that the course talked about things like regulation. But I've tried to read about this a bit and tried to find interesting written things about, well, what regulation should we have? And there's really very little written down.
In his defense, I believe that sometimes a class should not be popular, just as sometimes medicine is bitter. You know, sometimes you shouldn't be approaching a class for, oh, let's do what students think is going to be more interesting. Sometimes you just need to go down and deliver what is necessary, and sometimes it's kind of boring, and that's fine too. It's part of the game. You know, sometimes studying is boring. That's fine.
I don't think the issue with the course was that it was boring. I think the issue was that they didn't understand the value in learning about these sorts of things.
I see. So
And,
not proper
that means that I
motivation.
failed in conveying the value.
Okay. Okay.
I think this is a serious issue kind of for anybody kind of leaning to the left of the spectrum, trying to communicate with people leaning to the right these days. Is, you're trying to say like, this is hurting people, and it gets interpreted as like, you're bad, you should feel ashamed of yourself. And I think it's like, really, in that course specifically, it's really, really important that we kind of figure out how to get these ideas to people. And I mean, Philip, you know better than anybody that, just, you can't just say an idea and then have somebody, like, it's not downloaded into their mind and now they accept it, right? It has to be let in somehow. And this is something I'm really struggling with, is like, in a programming languages course, if I'm teaching that, can I somehow sneak in some of my values? I think somehow libertarian values somehow sneak their way into computer science curricula.
So I think the important value that we need to put into our courses is the value of truth. And the value of communication.
Yeah.
And the value of acknowledging and building on work done by others. I think students would rightly object. I have certain political views. I will occasionally mention them to the students, but I try to label those as, that's my political view. I can't say, you should have my political view. That's just not a valid thing for somebody to do.
But regulation is seen as kind of political. This is kind of the...
So one class that I
thing.
had when I was an undergraduate was an economics class taught by a Marxist. And I think I learned a lot from that about how to teach. So for one thing, he was sort of a combination of both Marxes. There's a bit of Groucho Marx in him as well. He was very entertaining. So that reinforced what I'd learned from other teachers about how important that was. But the important thing was he would teach us classical economics and how it works. And then he'd stop and he'd say, okay, now I'm going to tell you the truth, and teach us about Marxist economics. But the point is, he did his absolute best to convey this other stuff that he thought was wrong, but he tried to convey it accurately because this was the standard accepted approach. And this idea that you can disagree with something, but try to communicate it as best you can, I thought that was really important. When I talk about truth as a value, that's the kind of thing I have in mind.
What definition of truth do you have? Sorry about the deeply philosophical question, but it's something that kind of strikes me sometimes,
I'm not sure if I could give any kind of useful answer to that question.
Okay. Should we talk about writing? Can we talk about writing?
Sure.
In your view, what makes someone a good academic writer?
They want to communicate to their audience, so they think about what it is their audience knows. Lots of people, but there's a more general problem that all the people who do computing have, which is all you guys are extremely clever. And so you can take a very complicated solution. You can all learn and use JavaScript, right? I can't, right? You guys are all very good at making very complicated things work, and you just understand it. And the point is, for something to be more widely used, it has to be more accessible. So the fact that everybody is very clever really gets in the way of communication. Right? If you look at the people who've been very effective, people like Robin Milner or Tony Hoare, who are also, of course, very clever, but they spend a lot of their time trying to polish off, right? Take all the complicated little fiddly edges and find ways of polishing them to make them simpler. Right? And they try to think, what's the absolute clearest way to present this material? Right? And they will try it again and again and again. So they put a lot of effort into simplifying things. And I think many people in our field do not. And that's to the detriment of the field. And the things that will succeed are the things that you really work hard on giving a clear and simple presentation of, and figure out what is the clear and simple approach to this, rather than just taking the first approach that comes to mind. This happens at all levels. So like I spend a lot of time thinking about which letter am I going to use to represent this concept.
Yeah, I didn't realize the value of a good choice of letters until I read a paper where they were just chosen randomly. And I was like, wow, I have to remember 6 different letters that are completely have no rhyme or reason to them. That was an interesting experience. Can you think of specific examples that your students often would make when you were teaching a writing class, the mistakes that they would make, things that they would think I was communicating clearly, but I wasn't? Besides just kind of the general, like you should have a theory of mind, like an idea of what your audience knows.
So it's a little bit tricky going at this, right? Because you talked about before, if you say to somebody, this is being hurtful to people, they might think you're saying you're being a bad person. And similarly, if you say this isn't communicating well, right, people will say, oh, you're attacking me. So people need to have a mindset that says, maybe I'm not communicating as well as I want to. And if somebody explains something to me, or says this isn't working, I need to thank them for it, rather than try to discount what they're saying to me. I guess this is, again, right, when I talk about the value of truth, this is part of the value of truth, is being happy about criticism, because it's helping you rather than hurting you.
I think it has to do with maybe like we're all very insecure. We're scared that there might be something wrong with us, and so when somebody says, especially you, Phil, like you say things very directly and matter of factly, and it's very obvious what you're saying, but it's also like, oh my gosh, Phil's mad at me.
I think sometimes I come across as angry and upset, where I should work harder not to do, right? Because that gets in the way of effective communication. I hope I've mellowed out a bit as the years have passed, but yeah, it's very important to avoid making an effect like that. And sometimes I think I've had a counterproductive effect.
You've had a counterproductive effect on what?
Coming across as angry at people when that's not a helpful thing to do.
Yeah. These days, we kind of have a culture of like, if somebody sends you a text that ends in a period, that means that they're mad at you. So I put in like a bunch of, smiley faces. All of my punctuation have been replaced by like a picture of a monkey and then an elephant, just to indicate that I'm having fun.
Did I have a friend that if I send him a thumbs up, he thinks I'm very mad? I'm like, come on, man. I'm just agreeing here.
Yeah, it's tricky. I mean, so one of the things actually that I really love about your writing is that you make a lot of jokes. It's very kind of funny, and even though the sentences are short, they're short often in a funny way, in like a P.G. Wodehouse type of way. But I find that like I tried to do that when I was an undergrad, and I just came across as like really annoying and trying to punctuate everything with jokes and distracting from the work. Do you have any kind of like I don't know, a theory for how to strike a balance between being formal enough but also being entertaining? Because your writing is entertaining, I think, and that's a fairly unique property of it.
Thank you. I think I learned that, right. I mentioned all these influences on me when I was an undergraduate at Stanford. And one of those influences was, everybody was having a good time. Everybody would think that humor was a very important part of communicating well. Donald Knuth showed us his CV, and his first published paper was in Mad magazine.
I have to go back and revisit that if I can find his CV.
Right, I was very lucky. He taught a class on technical writing. And one of the points he made in that was that you should try to incorporate humor. And it's tricky, right? Because you don't just put in random jokes. You put in jokes that depend in a critical way on the material that you're covering. So I guess I absorbed some of that technique from them. And, it is hard. I have done things that I thought were hilarious and people said, don't do that. That's wrong.
And you said, thank you for telling me the truth.
No, I was a young graduate student at the time, so I was really annoyed with them. But they were my supervisors, okay. So I did what they said. But now I think I would be more grateful. Right? You get reviews, and the reviews criticize lots of stuff. And I work very hard now when I get a review to have a positive response to every single thing that's raised. Every now and then somebody will say, I didn't understand this bit. And I look at it, well, I think they didn't understand. I better make it clear. And I look at it, I don't know what to do to make this clearer. But only rarely. Usually I can figure out something to do.
Does some of your kind of writing style come from like fiction writers that you like or nonfiction writers outside of computer science? Like, I feel like you'd be a big P.G. Wodehouse fan. Am I right?
You're wrong. I've never read P.G. Wodehouse, I'm sorry to say. You having brought this up makes you think I better go off and read some P.G. Wodehouse. I'll put it on my reading list. Is there a particular book that you'd recommend?
I think it's like a series. That's the Jeeves and Wooster. Yeah, those are pretty
start
fun.
At the beginning?
Yeah, I think, or anything. I've only read, let's little bits and pieces of it. That's how I tend to read.
But one thing about thinking, right, it's my job to communicate clearly is this means anytime I'm reading something that's well written, I'm contributing to my job. Right? So I never need to feel bad about taking time to read something. Right? I subscribe to the New Yorker and the Atlantic just because I know they're really well written. So anything I read in there will be helping me to be a better communicator.
And those,
of course, really what I do is I go off and look at the cartoons in the New Yorker. But whenever I look at the articles, that's helping me to be a better communicator. Maybe the cartoons are as well.
Yeah, they influence your diagrams. Probably they make them. When you have figure 1 or something like that, you can pull from a cartoon or something like that. That's ineffective joke. I apologize.
You're also quite famous for the creative paper titles you have. Where do you draw your inspiration there? Is like the journals that you read as well? Is there anything particularly when you're writing a creative paper title?
I think I just fell into that because I came up with listlessness is better than laziness as the title for my PhD thesis, which I was encouraged in because Guy Steele was my one of my PhD supervisors, and he would be very receptive to that sort of thing.
Meaning jokes, or?
Yeah.
I mean, if you go back and read his rabbit it was his master's thesis, the rabbit scheme compiler, and that is immensely entertaining to read.
He has my favorite
so
PL talk, the one Growing a Language. I think it's just such a masterpiece.
Yeah.
Mm-hmm. Yes, awesome. That's so a brilliant talk. I agree.
Yeah. So I can see the influence there.
Oh, right. So how did I get started on titles? I think just that title worked out, and so I kept doing it.
Let me read a couple of them here for our audience. My favorite ones. While type programs can't be blamed, making a fast curry, see push enter versus eval apply for higher order language. E2, XML, the downfall of the relational empire. That's yours, right? 2 ways to bake your pizza, translating parameterized types into Java. This one is spicy. 3 sums, with and without blames. You were a co-author in that one, I believe?
Yeah, that was my title.
Your title?
I was pleased with that title.
That is
So
very
some of the titles you
spicy.
list, actually, I wasn't particularly pleased with. I think some of them were due to co-authors, but the threesomes title, I think, is an example of something that works very well because the whole point is all of those have very technical meanings. Something that my students consistently get wrong is they will use a pronoun or they will use a phrase like this. And when you use a pronoun or this, it should refer to the last noun phrase. And then you go back to the last noun phrase and no, that's not what they meant. They had in mind something else. And you're just supposed to sort of work out what it is. So I learned this in part from Ullman, who's wrote a nice article in Communications of the ACM about advising PhD students. And he made this point. This should always have a referent. And he gave some nice examples.
I think we covered a good bunch about writing. We are starting to run a little short on time. There is one question about your work that kind of stood out to me, which is how you often say, either in your biography, in your work, how your work is about bringing theory into practice and practice back into theory. And I think that can be very well seen both in your work and in generics Java and featherweight Java, right? Like one bringing theory into practice, the other one practice into theory. When did you first realize this was a strength that you could lean into? This is kind of like one particular superpower you have.
I'm not sure it is a superpower that I have. It is something that I try to do. I've been fortunate to work with a lot of people that have had a lot of impact on practice and developed a lot of good theories. So I think just being around people that made that work helped me to see that that was an important thing to do. I'm certainly far from the only person who's tried to do that. I think it was Faraday who said there's nothing as practical as a good theory. And so I've always tried to use that as a motivation. I think one place where I formulated this was one time when I was writing. Oh, yes, I used that phrase, which I didn't know at the time was due to Faraday, when writing the call for papers for an edition of PADL, Practical Applications of Dependent Languages, which was both about functional languages and logic programming languages. So I guess to a certain extent, I crystallized it when writing that particular call for papers. But I think this was just something that I was, just like I was very fortunate to have all these superb mentors. One consequence of that was seeing the importance of theory and practice and their interplay. And I think I remember getting lectures about this. I think, again, they were from Knuth. Sorry, you're. It's like you're asking a fish about water. I can't really
That's what
explain
I
this
keep
to you.
thinking
It's
in
just
my head.
all
Yes.
around me.
Like you just do it. You're just doing your thing, right? You're not. But do you think what is the deeper value of theory here? Is it because of communication? Is it because of understanding more deeply understanding what's going on?
I value those places where I can find a theory that has some application because it just gives you a signpost for working. So, the monad you can think of just as a a type signature. But if you understand their roots in category theory, then you understand, oh, it's not just a type signature. There are some properties that the things with this signature should satisfy. And these correspond really to very fundamental things like having an operation that's associative and has identities. The laws of a monoid, which is where monad gets its name because it behaves very similarly to a monoid, and in fact can be formally viewed as a monoid if you look through just the right lens. But having those laws was just, for me, that was the key thing there, not the type signature, but the fact that, oh, and then these things will satisfy these laws. Because you get some consequences about that. There, you can write things this way or that way, and it doesn't matter. But also you get something that helps you to orient, right? When you come up with one of these things, you can check, well, wait, does it satisfy these properties or not? If not, that's a sign that maybe I should be doing it a different way. So it's can be written down very compactly, and yet it gives you a very practical guide to what you're doing. So that's what I like about theory. And, the world's a very messy place. I was very young. The idea that, I would have dreams about purely geometric spaces. And then when I discovered that you could represent those in a computer, I was just like, oh, I want to do this. So the notion that these very clean, simple things can guide you in the world, which is actually a very messy thing, I think that's what I like about all this.
Cool. I love it. That's beautiful. That's awesome. Do you have anything to add then?
Me? Well, I am kind of curious about. Well, actually, before that, I know Phil, you said you had a question for us before you started. Did that get kind of addressed during this?
Yeah, you gave me this long list of questions, and like what one was, you listed all the people who I'd worked with at Stanford. I was like, how did you even know I worked with all these people?
That was me. There is an article at IOHK blog when you got the ACM fellowship with a lot of those stories.
Okay.
That's where I got it from.
Okay. That would explain it.
Yes, that was a very entertaining little piece of writing.
Anyhow, I want to commend you on doing excellent research for this interview.
Thank you. Okay.
One of the questions that you listed was if I had any favorite writers.
Yes.
And I don't really, but made me go back and look up a writer, because I remember many years ago, I think it was back when I was a postdoc at Oxford, going to see her speak. I'd read a couple of her books and just really liked them. So, the audience gets asked questions. And at one point I said, this reads so smoothly. How did you do that? And she said, oh, just because I do 10 drafts of everything.
Wow. Who was this?
This is Alison Lurie, I believe. I'm not, I said, who's the author of these two books? And that turns out one of the books was by a different author. But I double checked. I think it's Alison Lurie. For me, that was an important thing to understand, that where does the quality come from? Just from doing what you should be doing and not giving up, doing it over and over again. And you can find the same thing. If Tony Hoare has written about his process of writing a paper, and he talks about he writes the paper, puts it away on his shelf, takes it out 6 weeks or 6 months later and looks at it and rewrites it. I think that's actually a very important thing to keep in mind, which is this stuff that seems like it would be impossibly difficult, writing 10 drafts, is something that's actually worth putting effort into. That, the simple steps of making things better, if you just repeat them again and again, you get a lot of effect from that. And that it's worth doing that.
I think that's really undervalued, especially nowadays. Like there is so much pressure onto us PhD students and into tenure, like professors applying for tenure to just ta- put out as many papers as possible, as fast as possible, and really starts lacking on depth and quality somehow, right?
It used to be that a university was a place for the tiny fraction of the population that wanted to study and to push knowledge forward. But what we found over the lifetime that I've been in university is that you have more and more managers coming in saying, oh, we can't just leave you to do your job.
Right.
We have to be continually evaluating you. And so time goes into that. You need to be continuously getting money from the government.
Mm-hmm.
And so, on the one hand, that's valuable because you do get the resources to do what you do. And you can't just give resources out willy-nilly. But on the other hand, a lot of time goes into trying to procure those resources. And also, there's been this push to say everybody should go to university. And, on the one hand, saying everybody should have these opportunities is great. But I think having a place that's not necessarily for everybody, but that's just for people that want to go into things in depth is important. And we've lost that. So it's great that people have access to things that they wouldn't have had access before. But it's a very unfortunate consequence of this that the whole nature has changed and the space for people to go into things deeply is reduced. It becomes harder to get students that are at the same level. And so, you have to meet the students where they are, so you can't go as far. And so that takes longer for the people who want to reach this level to reach that level. So we've seen over the course of years, I've seen it over the course of my life, these systems become less effective at being a space for doing this sort of thing because of you began by mentioning the pressure on people to do these things you need to do to get tenure. And it used to be the whole point was once you had tenure, then you wouldn't be under this pressure. But the system doesn't really work in that way anymore. And Mitch Wand has done, not Mitch Wand, Shavade has done a great job of pointing out that if people like Bertrand Russell, when they were coming up with formal languages, right? So formal languages, have been immensely valuable, and they underpin huge amounts of the structure that we use for computing today. But if Russell and Whitehead had to make an argument for what they were doing to the funding bodies today, they were just doing stuff that was philosophy. How could you justify that as having any practical value? It turned out to have huge practical value. But the ways in which you would have to justify that in advance now, it would be very difficult.
I'm so happy you bring this up because it's something that is really bothering me for the last three years, ever since I decided to drop my PhD and deciding towards going back to academia, because I don't quite see how, like science is being developed in a very, very different way these days. And we don't see really a light in the end of the tunnel. Do you see a light in the end of the tunnel about that? Do you see like how we can go make things better somehow?
Well, there are a lot of problems in the world these days that seem intractable. Right? It's very clear that we need to do things to improve the environment. Right? That we're pumping too much carbon into the atmosphere, and that's going to make the planet unlivable. But people make a profit from that, and they use part of that profit to ensure that their point of view is very well represented in the media and very well represented among politicians. And so the people want one thing, but the system is pushing in a different direction. I think the people want all the benefits that we have from the system that we're talking about being under pressure. But the system itself is pushing in an opposite direction. I think people will need to do much more to get organized and work together to push against these huge forces. And it does seem very, very difficult. And no, it's not clear to me how we do this. And, I think it's an open question. Is the system going to collapse? And then maybe the next system will solve this? Or will people, as it starts to collapse, will people get together and organize and push against it? And, we saw sometimes when people began to get organized, like the Occupy Wall Street movement that happened after the 2008 collapse, but it just wasn't strong enough. And it did not succeed in its goals. So the question will be, what will be the next one of those, and how will that push things forward? And we need to be open and helpful to trying to organize in those ways. Back when the internet was new, many people thought it would help people to organize in those ways. And what was not predicted is that the whole thing would be controlled by a tiny number of big companies. And if somebody could work out a way to restore the system to ways of letting people work together, which you can within some of that framework, but we need right. I haven't seen yet what's going to do it. Right, we've seen things that look like they might do it, and then they fail to succeed. I think that it's hard not to just face that and despair, but I think despair is the worst thing that we can do. So we need to be open and looking around for where we can contribute in a valuable way. And I'm very hopeful that people in the next generation will do something.
That's what we're doing. That's one of the big beliefs that I have with this podcast. Is my little piece that I can try to assist with that particular problem. Like inviting people like you and trying to get at the depth of what is going on into the historical perspective and things like that. So this is a problem that touches me very, very deeply, and I'm very happy that you brought this up, and you are very honest.
I think your insight that an important step to a good future is to have a good understanding of the past.
Yeah.
And to know what's happened in the past that you can build on is a very important thing to do. So in that sense, I completely agree with what you're doing, and more power to your elbow.
Thank you. Thank you. We have just hit the 2-hour mark of when we first started, not the recording, but meeting. So I think this is a good place for us to finish. I don't want to hold your daughter from having you. So that's right? You said that your daughter is coming over or something?
My daughter's coming, and you might have heard a door open, which was my wife. So,
telling
yes,
you.
I have to go return to my family, please.
Perfect timing. Awesome. Well, thank you so much for being here with us. We deeply, deeply appreciate. Thank you for your insight, and hope to have you over again in the future. We still have plenty to talk about.
It's been a pleasure. Thank you very much. It's not often I get to do this. I've done a couple of times in the last week an interview like this in depth, but it's fairly rare for me, and it's a something I'm deeply appreciative of. So thank you very much.
Thank you. So back in June, when I went to Zurich I took the opportunity that I was in Europe and also flew to Lambda Days in Krakow. And there I met Philip Wadler, and it was a kind of a funny story because I was hanging out with Ryan Brewer. Big shout out to Ryan that he's currently assisting me managing Discord and things like that. We became great friends after episode 49, where he came to be a guest. We were sitting down waiting for the next talk, and he's wearing the beta reduction cap, which is a very nice cap. But so Philip Wadler sits next to him and asks where he got the cap. And I step in and give him my card. Look, it's in this store, Type Theory for All store, and you can find it there. But if you come and be a guest in the show, I'll send you one for free. How about that? He's like, okay, yeah, sure. So we exchanged contacts. I sent him an email. It took a little bit longer, as you can see. We've been working this since June. It's been more than a month that this episode has been recorded. And only now we could get it out. I think this was recorded like a week after Derek's episode. So it was like back to back. That was kind of busy this month. Hopefully it's still coming out in September. That's my goal. Still coming out like towards the little end of September, but it's coming out in September. So that's the important bit. So yeah, that's the story. Philip Wadler, that was great. That was incredible. Philip Wadler is a legend, a living legend in our field. So always strikes me how these great people are willing to come and hold this conversation and teach all of us, right? Communicate their ideas. The whole point of the whole thing is to communicate ideas, and Philip Wadler surely has been working very hard to communicate ideas well throughout his career. So great stuff, awesome stuff. Really appreciate that. Thanks Philip for this opportunity. So yeah, the mentorship. There is the mentorship program going on. You can go to the website. There is a nice little tab here with this mentorship going on. Don't forget to check the stuff in the store. We currently have all the cool mugs. We have Brock mug, Lean mug, Isabel mug, Agda mug, Haskell mug, Ocamo mug, and of course Type Theory for All mug, which is my own favorite because it has some really cool watermarks on it. We also have the Lambda, the beta reduction cap, and all that fun stuff. If you just like the show and you want to give some support, go to our Ko-Fi #Type Theory for All. If you just want to say hi, go to contact. There's contact tab as well, or send an email. Send an email to contact@typetheoryforall.com. Send us what are your thoughts, what do you think about the show, suggestions. I'm always very, very open to suggestions. I'm actually considering to open a Patreon and have like some paywall on some stuff, because I wanna build this community some more. I feel there are some pretty cool people kind of lurking, just listening in the behind. And I think I would like to produce content just for you, to go a little bit more in depth. So I think if you are listening, if you have the trouble to listen all the way to the end, like now, you know that I always like to bring some more depth, some more insight, some more thought, which I usually don't do throughout an episode, But I think I would be very comfortable to talk more deeply about stuff in Patreon. So I wanted to ask what you guys think, if you would be interested in that, to have some more heartful conversations, with the camera like we're doing now, but in some particular topics about, I don't know, maybe grad school, about some topics in programming languages, some stuff that I'm working on. What are your thoughts? Do you have suggestions as well? So what are the things that you would like to see? Some blog posts on this Patreon. I don't know. I am still maturating this idea. So if you guys have some thoughts, let me know. And Twitch is probably coming back next month or November, probably November. I'm doing some stuff in October, and keep your eye open on that. some interesting stuff coming on that end. Probably some more rock hacking on that side, or lean learning, or both. Let's see. So yeah, I think that's it. Keep you guys healthy, keep you guys sane, keep you guys going. See you guys next time.